Next LeetCode question we have is a valid Sudoku. This question is really straightforward. I mean, this is a medium question, but let's see. Mostly it involves a couple of math concepts, and so we have three conditions here for a Sudoku board to be valid. So there is a 9x9 Sudoku board, and we have to determine whether it's valid or not. Only the field cells need to be validated according to following rules. Each row must contain 1 to 9 without repetition. Each column should contain 1 to 9 without repetition, and each sub box, that is this small box that is of 3x3, it should also contain 1 to 9 without repetition. So we need to assess these conditions and tell whether a Sudoku board is valid or not. So the logic is very simple. I mean, let's see how we'll do that. So this is a question. So as we have saw, like, there are three conditions to check whether a row contains without duplication. We can do a nested loop with I comma j. Similarly, with column we can do a nested loop with I comma j, and we need to maintain a set for to determine whether this is a duplicate or not. And the real problem starts in this sub box of 3x3. So if we can explain you with the code. So this is our Sudoku board. Let's try to divide this. One, two, three, four, five, six. Instead of, I should have done this thing. So this is our Sudoku board. We'll maintain a set for row to keep track of duplicates. We'll keep a set for column to keep track of duplicates. We'll also have a set for sub box, that is 3x3 box. So this is our set. So because this is a 2D array, you need nested loop for traversing both row and column. So that's how you will do this. This is our nested loop, and we are checking, is this number a duplicate in this row? If such, we are returning false. So that's simple. And similarly we are doing for the column, and for the column we are swapping board of ij with board of ji. So instead of going left to right, will be going top to bottom. That's simple. And here for this sub box, we know there are 9 sub boxes, so let's add, this is one. Oh, sorry, I mean, if I write, it will be so small that we can't kind of understand it clearly. So first, second, third, fourth, fifth, then we have sixth, seventh, eighth, and this is the ninth. There are 9 sub boxes. Okay, 9 sub boxes, right? Next thing you need is, for each sub box you need its start row and start column. For example, see here. How can you check in these sub boxes? Only if you know at what row and what column they are starting. If you know that, then you can do a nested loop of 3 and 3. Then you can do similar check duplicates logic there. The question is, how will you know that? So there is a pattern, if you see here. So if you see for rows, the sub boxes are starting at 0, 3, and 6. 0, 1, 2 and 3 another box, 4, 5 and 6 another box. So it's same 0, 3, 6, 0, 3, 6, 0, 3, 6. Sorry, it was column. So every sub box is starting at 0, 3 and 6 columns. I need to note down here. Column start. This is column start, okay. And now if you see at row start also, similarly row start also starting at 0, 1, 2, 3, 4, 5, 6. So row start is also at 0, 3 and 6. Now the question is, how will you know? How will you get this start and start column starts and row starts indexes? So for this you need to kind of see few patterns in this. The patterns are, the start column is 3 into box number modulo 3. This gives you 036, 036, 036. 036, 036, 036. Great. How? Let's iterate this. For the box 1, first box the index will be 0, right? So 0 modulo 3 is 0 and 3 into 0 is 0. Okay. Next, if it is 1, 3 into 1 modulo 3 is 1. 3 ones are 3. So 3. Again 6. So the pattern will keep repeating itself. 036, 036, 036. Again you need row start. How you will get row start? So here box number is 0, 1, 2 and here 3, 4, 5 and here 6, 7, 8. So we can see a pattern like it is somewhere related to multiplication and division. So the formula is here. So start row is take the floor of division of box by 3. So 0 by 3, 0, 1 by 3, 1, and again same the logic repeats. And if you can see this here, if it is box number 0, 1, 2, 3, if it is box number 3, 3 by 3 is 1, 1 into 3, 3. So here you will get row number 3. Let's iterate it for this 7th box. 1, 2, 3, 4, 5, 6, 7. So here you need a row number of 6. How you will get that? At 7, 7 divided by 3 is 7 divided by 3 is 2.3. If you are taking 2.3 ka floor of 2.3, that is 2. 2 into 3, that is 6. So here you will get a 6. So this is something you need to know, and it took a while for me also to figure out this pattern. So you have 9 boxes, and from those 9 boxes you need to get column start and row start. After you get that, you'll just loop over with a nested loop of 3 times. So for row 3 times, and for column 3 times, for row 3 times. I've done it reverse, you can do it reverse. The result will be same. And we are checking if this is duplicate or not. And if it is duplicate, it return false. And if this Sudoku board has passed all the 3 tests of row, column, and the boxes, and still it's not returned, means this is a valid Sudoku, means we have to return true. And the logic of this duplicate is very simple. You get a number and you get a set, and it just checks does that number already exist in the set. If so, we'll return true, else we'll add that number into the set. So this is the logic of the Sudoku board problem. And what I was telling to reverse here, instead of starting with column and row, we have also done it with row and column. So it's just preference or style of writing, and doesn't change the logic how the program runs itself. And if we talk about complexity, the complexity of this would be a kind of constant. Why? Because this is a fixed size Sudoku board, right? But still, for every cell we are uh, doing it nested loop row, so it would be of n square complexity, and we are creating a of set of size 9. So that is O of n, complexity of space. Space is O of n, time is O of n square. Also mentioned that Sudoku board is like fixed size, so technically both are constant, because the board is not gonna increase from this. So that is the point. Let's try to run this program. I've also kind of tried to log what would be the start of column and row for each boxes. So box 0 is 0 comma 0, box 1 is 3 comma 0, 2 is 6 comma 0, 3 is 0 comma 3, and all that. So let's run the program. I've already tried this. We're trying it again. So that's it. This question is done. Main logic is this thing. I mean, if you can understand this one, if you can understand this thing, how we are using modular operator and division operator to get the indexes of rows and columns, and it depends upon the box number, box index, then this question is not very difficult.